All right, moving on. No more grape talk. No more dog talk. Um, Today we're going to hit chapter 11. Believe it or not, we have 2 weeks left. Both of those will be chapter 12. Yeah. Starting out today, we're going to see something called abstract data types. That's this block right here. And you've actually made an abstract data type already. When you created class rectangle, you made a new data type. And like I was just doing in the last class in 121, public static, goodness gracious, blank, some method, some method, blank. And you know that you could back in Java, we started with voids. We had ints, we had doubles. Everything in here was the name of a data type. In fact, you got to the point where we did rectangle and we had a return type of rectangle. That rectangle that was being returned, return R1, you're now becoming experts on because this returned an address. So we were able to pick, but this was a new data type. Over here, we could have had rectangle being passed in. The address from my argument was brought down and put in this parameter list, but my data type was rectangle. CPS 162 is all about creating new data types to work with. And as you saw in here a moment ago, I put information that these are going to be called abstract data types dash 162. We just keep making up more and more data types. A lot of the data types are going to be built off of this thing called a structure. It's going to include a structure. All right, let me pause for a second. We'll see how long that lasts. Okay, so an abstract data type. It's going to be created by a programmer. It has its own range of data. This one's going to be a little bit different than what we saw in a class, but at the same time similar because remember in a class we had all those fields can have its own operations. In a class we had all of those methods that we could perform on. So we made a data type. All right. So structures, the one we're talking about today. I think all but one did the code listings. I have to go back and check because we had 22 out of 23. A structure is going to be several variables put together. Unfortunately, that's only this guy, range of data. We don't have any operations going on with it, but it's a baby step that we're going to eventually combine this structure with pointers. What do I mean by that? Well, we start to take a look at a structure and we have a tag, usually starts with an uppercase. Our variables were always camel case, starting with lowercase. It's a new data type. This guy right here, the tag, is a new data type. And if you look down in one of the examples, employee is now a new data type. And back in that, where is it? List, I would now be able to put employee here. It's a new data type. That doesn't do a lot, but it's like the old fashioned Rolodex where I can, in one variable, hold more than just a name or just a number. I can hold several different data types. So my new data type is called employee. Inside of it We in the old days there used to be these things called Rolodexes sitting on a desk, had name, contact number, address, and phone, and you would flip through and find the cards you need and get on the phone that was connected to the wall and actually make a phone call. Quick thing to notice, there is a semicolon at the end of my data type. So now I'm going to be able to create new variables of this data type, and let's see how we work with them. Chinga, 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 chinga. Oh, I need to make sure I cover that as well. Okay. So in order to do it, in order to access this struct, you've seen where I have to do the period. And you're all pretty smart. You understand I need this access, the dot operator to allow me to say, okay, so I created a variable circle1. It's of type circle, meaning its data type is circle. And if I want to actually look at an individual field, I do the dot, for example, radius of a circle. Starting out nice and basic. If I want to compare, you see a sad face here. That's an alien of some sort. Because if I said if circle 1 equals circle 2, is that a correct statement? I see people shaking their head no. The answer is yes. But what's it comparing?
Nothing.
Memory addresses.
The addresses.
Yeah.
Excellent. It's comparing the addresses. If I want to find out if the information is the same, I'm doing circle dot radius equals circle dot radius. And I don't know if there's more information about the circle or not. Circle's not a good one because when I think of circle, all I think about is the radius. So in order to do this, I have to actually do a little bit more. And instead of doing this shallow comparison, I need to do more of a deep comparison. Okay. Created a struct. The struct is called city info. City starts with a capital C. Still camel case, but it helps me a little bit in knowing that it's a data type, not a variable. Inside of here, that's actually a lowercase c. I have several fields. City name, state, population. I now create a variable city. Looks like I have not taught or computer science taught overloaded type of default constructor. We've overloaded constructors before. This is going to be similar to that. We had a default, we had one variable called side, we had two called length and width, going back to CPS 121. But if you look here, this will do sort of like an implicit initialization. It'll store Harrisburg in city name. State and population are left blank. I could do Harrisburg, PA. Population is still. Quick guess, what's the population of Harrisburg?
39,299.
Is that what it is, Jack?
I'm assuming so.
Oh, did you look it up real quick?
No, I looked at your paper.
Oh, that says 49,299. Hey Siri, what's the population of Harrisburg, Pennsylvania?
At least 5 or 6.
50,135 as of today. 50,000 is the population of Harrisburg. Why are you making faces, Andrew? Just Google
That seems a little low. That feels a little low.
it. Why is Harrisburg one of those cities that won't grow very high? Because it's locked by a river. Harrisburg's considered an old city. Other old cities, Chicago is an old city. It's landlocked, right? It's got the Great Lake over there. Boston, Philadelphia. What's the
Most
new
cities
growing?
in the
What's that?
north. Most cities in the northeast area.
Yeah. Take a look at San Antonio, Houston.
Hell
Look at
yeah.
the way their numbers are growing. Okay.
Dallas.
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 Go Birds. That's all I'm gonna say. So
Hi, buddy.
50,000 is the population of Harrisburg. Yeah, go Birds. Hey, good. Where am I at? Any questions on what's going on with this? Okay. Some things that, and I'm not going to bother looking at code listings, even though I have them listed here, but I might glance at these two as arguments. Said that over and over. We just looked at an example where I can have anything as a return type. And again, what's going to be returned is an address. And I can have anything being passed in. What's being passed in is an address. So you guys did these code listings and you got a pretty good idea of what's going on there. Structs are not too bad. We're going to do a program with structs, but not just yet. So questions. Questions on a struct. Now, the other thing here in chapter 11 is something called an enumerated data type. And this is one that's set up mainly for programmers. Okay? It's not very well used outside. I don't I, I can go back to a basic enumerated data type. The basic enumerated data type is right here. It's Boolean. Boolean has the values of what?
0, 1, true or false.
False or true. I wrote it in a specific order. False or true, because what number goes with false?
0.
0,
What number goes with true?
1,
What comes after false?
True.
What comes before false?
True.
True. They wrap around. Okay, they're called ordinal. They have a predecessor and a successor. Well, a Boolean data type, as you saw, is similar to this. You notice neither of these is like a string in double quotes. It's written a little bit different, where false is the first thing, it represents the number 0. True is the second thing, it represents the number 1. You saw examples where we have Monday, that's 1, Tuesday, 0, that would be 1, Wednesday would be 2, and that might be my list. This is a Boolean, an enumerated data type. Boolean is an example. Words used to represent numbers. They have, like I said a moment ago, a unique predecessor and a successor. Mentioned already, programmer defined. We're defining it. We're starting with enum. We're making a data type called day. The keyword enum, short for enumerated out front, dictates how we work with it. We have a list of identifiers, Monday, Tuesday, Wednesday, Thursday. These are not in double quotes. These represent numbers. Monday represents 0, 1, 2, 3. I've never come up with a good program for students to do based on this. Okay.
Just
Here's an
because you could just
example.
use the numbers.
Yes, just
Yeah.
use the number. Here's a data type day. Work. I can assign work the value Wednesday. If I see out false, I would get a 0 from the Boolean data type. If I see out Wednesday in a program I'm working with, it would say, hey, that's a 2. Can I compare them? Yep, I can compare them. X can get, well, first of all, X can get the value of whatever Tuesday's number is, 1, and it would display 1. Do the relational operators work? We know we have 6 relational operators, less than, greater than, on and on and on. Code listing 11.9. There we go. Monday is 0. We're going up to 4. We're entering salaries. Sales sub Monday. It's just sales sub 0. This guy's just going through finding a total. Again, I don't really have a clever kind of enumerated day. All of that's going on there. An array. Workday equals 0, while workday is less than or equal to 4. It'll get in here and do some work. Oh, check out this. Workday equals static cast day. Ooh, blah, 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 blah. What's that do?
It turns
I know
it
it would change
into
the data type.
word.
Sorry.
It's like it's casting it as the word instead of the number.
So that we can do the increment. There's the +1 that gets added each time. So there's a couple examples in here. We did not get into it in 161. You would see it again in 162. Again, there's another example of that loop. There's an example of it being used as a subscript. Over on this page, we get an example of using them as, oh, check this out. I'm passing it in. As always, data type, the address is going to go to D. Depending on which one it is, I could display it. Monday, Tuesday, Wednesday, Thursday, Friday. So they spend a lot of time in section 1111 about it, but yeah.
I have a question.
Yeah.
With enumerated data types, let's say you like assigned the first data type a number that's not 0. Do all the other
Crash.
like data types adapt?
Yeah. I'm going to assume that would crash.
Oh, crash, really?
Yeah.
I figured if you assigned, like, for example, if you signed Monday 1, all the other data would just adapt, like Tuesday would become 2.
No, that'd be like trying to set false equal to 1
Interesting.
and the assignment operator. Because remember, it's not a variable, it's a label.
Yeah, but doesn't it have a value?
So you're saying that Monday is 0. Can I change it? I would say no, it's going to be more that it's a constant
Okay.
kind of deal.
I have a secondary question.
Go ahead.
So enumerated data types go above your main along with structures. Is there a certain order that we need to put our function prototypes, enumerated data types, and structures, or does that not matter?
I think that would matter. Yeah, I wouldn't think that would matter. Okay, so we're going to have 2 programs. This would be day 1 and the second part day 2, but you get it all in day 1. You're going to write a program inside of a data file. You're going to have the number of students followed by the name and 3 test scores for each student. So your data file is going to look something like, if I have 4 students, that would tell me how many times to run a loop to input the data. Something different. We haven't seen this before. But yeah, it's an idea. Bob's 3 scores, 20, 40, 60. Chet, 100, 100. Chet's a kiss up. Mary, 80. Let's see, that average would be 40. That's nice. 100 would be the highest. Mary, 80, 88, and then she didn't bother taking the 3rd test. And Susie got a 90, a 94, and a 98. She kept getting better. So this would be an example of a data file that we would use. Okay? What do you think would be a great place to store this? In a
Structure.
structure. Okay? The structure could be string. We're going to go int, and int. or it could be a string with an array of size 3 of integers, depending on what your needs would be. So you can store it however you want. So you're going to you are going to read all of these in. Now, after part 1, we're going to see part 2. I don't know what STOI means, but that's up there.
Isn't that string to integer?
Yes. Display the name and average for each student. Okay, I can do that. Display the highest score and the student name. So out of 12 tests, what was the highest score and who had it? Display the lowest and display overall for all of the grades. Now, that's the easy part. We're going to beef it up a little bit. And what I want you to do is now read everything in the number of students, but store it all in an array. So when I read in the number of students, I'm going to see there's 4. I'm going to create an array of size 4 of structures. Now, you're going to get excited, but my array, I'm going to have my array name followed by the subscript. And as you know, so let's just make array name. And if I gave you that, you know that to be an address. If I gave you this, you know that to be an address. But we're going to follow it with something like dot name. So we need the front part to just be like any other front part. Then the field accessor will follow. Okay? A data
So-
file. First number is how big the array is going to be. You're going to read everything in and store it in that array. So you have an array of structures. Then you're going to go through and display the name and average for each student. After that, you're going to display the highest and the student name, lowest and student name. So you just have some accumulators that you're going to work with here. Read everything in as strings. Questions?